Hey everybody, this is the toolkit for Unit 5, Lesson 1, Investigation 1, where we are solving quadratic equations and using or finding the quadratic formula. Alright, so first off, what does it mean when we say solving? Well, when we're solving, we're trying to find the x-intercepts of our graph, or of the quadratic equation. Okay, so all that's doing is just finding the x-intercepts. Nice and easy. And usually what we try and do is we try and put it into the equation into factored form. That makes it the easiest for us to find the x-intercepts when we're solving these things. So if we can factor it, we'll do that. If we can't, then we'll use the quadratic formula, which we'll look at in a second. Alright, so let's start with how this starts. So we start with ax squared plus bx plus c equaling 0. Now the key thing here is this 0. But don't let that trip you up. This is still just another way to say f of x equals this function, whatever the function is, whatever our a, b, and c is. And the only difference is that we're now saying, instead of writing in f of x forms, is we're saying this f of x is equal to 0. So the y value equals 0. So what is the x value when y equals 0? And that's why we're getting the x-intercepts when we do this. So if we can, we rewrite this in factored form. We look for anything common amongst our a, b, and c. So if there's a constant value, like maybe they're all divisible by 2 or something like that, we'll factor that out and we'll put it into factored form. So again, this k, that's that common piece. That's the thing that you can factor out. It's easy to just divide everything by that value. But it's better to factor it out, even though it does go away at some point, just to make sure that you're keeping it opening up or down if you have to factor out a negative or a positive, you know. So it's always a good idea to keep that k there and not just divide everything out. And then we have our two pieces. We've got x minus p and x minus q. Now, when we look at this first part, x minus p, if we set that equal to 0, since we've got three things that are being multiplied together, if we set this equal to 0 and we solve for x, then we find out that our intercept is at point P, whatever that is. And same thing with x minus q, that if we set that equal to 0, then we'll get the value x equals q. So our two x-intercepts here would be P and q. And of course the y values are 0 because it's an intercept. Now, so we've talked about that before, so that should be pretty apparent to you and just be a little bit of a review. Now, we could also see it as x plus p and x plus q when we factor. And all that means is that when we set each of these parts equal to 0, now we'll get a negative p or we can get a negative q. So the big idea here is that you're setting each of the factors equal to 0 to find out what value it would have to be to make the whole thing 0. So let's look to see what happens with this when we have an example here. So we've got x squared plus 5x plus 6 equals 0. This one should be pretty straightforward to factor. So we got x plus 3 times x plus 2 equals 0. So we're going to take each factor and make it equal 0. So x plus 3 equals 0, subtract 3 from both sides, so x equals negative 3. X plus 2 equals 0, subtract 2 from both sides, so we get x equals negative 2. So here's how this works, right? So if we've got this negative 3, if we were to plug it into our x, maybe we could plug it into both x's actually, but if we plugged it into this first x, that would make this whole factor 0. So when we take this 0 and we multiply it by x plus 2, the whole thing becomes 0. So that's how we know that this is one of our x-intercepts. And similarly, if we take this negative 2 and we plug it into this x, then this factor becomes 0. So no matter what's on the other side, positive 1, negative 1, whatever is over there, it doesn't matter because that's also going to become 0. So our x-intercepts are negative 3 and negative 2. Okay, let's look at a slightly different example. So we're going to look at 15x squared plus 25x equaling 0. Now, this is a little different because if you notice, we don't have a c value here. So what do we do if we don't have this constant at the end of our standard form? Well, we just look for whatever's common between the factors that we do, or the terms that we do have. So in this case, what's common is an x in both terms, and we also have, they're both multiples of 5. So we can factor out a 5 as well. So we have 5x, and then you have to think, what 5x times what gives us 15x squared? Well, that would have to be 3x. And then 5x times what would give us 25x? Well, that's just going to be a positive 5. So now we've got this thing factored. We're still going to set each piece equal to 0, so we'll still say 5x equals 0, divide both sides by 5, and we still end up with x equaling 0. And 3x plus 5 equals 0, subtract 5 from both sides, divide by 3, and we get x equaling negative 5 over 3. And this still works just like before. If we plug this 0 into this x here, then this whole piece becomes 0, and this, so it wipes out this whole factor as well, so everything becomes 0. And similarly, if we plug in this negative 5/3 into this x here, then the threes would cancel out when we multiply the fraction and the whole number, and then we have negative 5 plus 5, so this whole thing becomes 0, and that means this whole side becomes 0, so we have our two X-intercepts again. Okay, so that's really how this works. Alright, so now what if it's not factorable in any way at all? Then we have our quadratic formula. And the quadratic formula is x equals negative b over 2a plus or minus b, the square root of b squared minus 4ac over 2a as well. You might have seen it in as one big fraction, but we're going to look at it two separate fractions just so we can find out some more information about our graph. So we use this still to find the x-intercepts, and for this one it must be in standard form, so we're not going to factor it out. And the reason we're not going to factorize it is because the equation, when we use this, generally is not factorable, or it's not easily factorable. So if it's not one that you can quickly do, sometimes the quadratic formula is the best way to go. There's more computation this way, but it might be a little bit easier to calculate than going through the process of factoring. That's kind of a personal preference, but you should know how to do both. Okay, so let's look at an example. We've got x squared plus 3x minus 10 equals 0. So up in this quadratic formula, we've got all these letters a, b, and c, so we're going to use those values from our standard form in our example. So in this case, a is the coefficient of the x squared, so a is 1, because there's nothing there. B is the coefficient of the x, so that's positive 3. And c is the constant term, so we got negative 10. So all we're going to do is we're just going to plug this into our equation. Negative 3 over 2 times 1 plus or minus. Now we've got this square root of b squared minus 4ac thing. So we got square root of 3 squared minus 4a, so 4, a is 1, and c is negative 10, and all that's divided by 2a. Okay, so we simplify, we get negative 3 over 2 for our first term. We still have our plus or minus here, and 3 squared is 9, and negative 4 times 1 times negative 10 is positive 40, divided by 2. And we still have our negative 3 over 2 plus or minus square root of 49 over 2. So we get x equals negative 3 plus or minus 7 over 2. Now, this plus or minus means that we have to find both of those pieces. So we have to set, or we have to solve each one of these. So let's look at the plus part first. So we get x is equal to negative 3 over 2 plus 7 over 2. So when we add those together, we get 4 over 2, which simplifies to positive 2. And when we do the minus piece, we get negative 3 over 2 minus 7 over 2. So that's going to be minus 10 over 2, or a negative 5. So these two should be our x-intercepts. So let's throw this onto a graph real quick, just so we can see some kind of cool parts of this quadratic formula. So here we've got our graph, and the x-axis is going to go by single units. The y-axis is going to go by the units of 2. So just to keep track there. So we got going down by 2s in the y and 1s in the x, just so I can fit it on the page here. Okay, so we start with our x-intercept of 2 and our x-intercept of -5. And if we were to graph this thing, generally what we do is we try and find the middle piece. So we're going to find the minimum or the maximum. And we take the average of our two x values, and we get -5 plus 2 and divide it by 2, so that's going to be -3 over 2. And that would put us at, that's -1.5, so that should put us right about here. But this should ring a bell because we just did this -3 over 2 over here. So when we're looking at the quadratic formula, that first part of it, that -b over 2a, is the x value of your minimum or maximum. That's kind of cool, I think, you know, that in this big formula we can find that value right away. So if you need to find that minimum or maximum and it's in standard form, just take that x value, or to find the x value, just find -b over 2a, and you've got the x value of the minimum or maximum. Now let's look at the next part. So let's say we wanted to move from the x. Oops, sorry, I got ahead of myself here. So like I said, this is the x value of the minimum or maximum. Okay, so now let's say we wanted to move from our x-intercept to our minimum value of x. So we just moved 3.5 places. And if we go from the other side, we're also going to move 3.5 places. So when we move 3.5 places, that's the same value as 7 over 2. 7 divided by 2 is 3.5. So here, when we add 7.2 to our -3 over 2, we get this this x-intercept. And when we subtract this 7 over 2, we get this x-intercept. So that's another kind of cool thing, is that this piece here, this whole big second part, is the distance from the midpoint to the x-intercepts. So, you know, often we see this formula and we just think, oh wow, yeah, that gives us the x-intercepts, but it actually gives us a little bit more how it's formulated there. It's kind of cool. Right. So let's see. So let's find the y value of the or of the minimum or maximum. So we're going to plug in our -3 over 2 into our formula, and we're going to do some calculations. Hit that into your calculator. Pause the video if you'd like to do that on your own. But you should get -12.25. So we have our points down here. I've already plotted our -12.25 for that for the minimum value. And then I've also, I kind of skipped past it here, you may not have noticed, but I also put in the y-intercept at -10. So we've got a few points. We've got our x-intercepts, so now we can graph this, and we get a parabola that looks something like this. So, so a little bit of information here. The big ideas are, again, the solving, so you're finding the x-intercepts and the different parts of the quadratic formula, and how they can help you plot your graph as well. So hopefully this was helpful, and we'll talk to you when we get to the next toolkit.